Welcome to the first video going over the VIPER mainframe emulator. I started this project because I am currently working with a legacy COBOL application, not as a developer, but I work with the developers, and I see them struggle on a daily basis. They don't think they're struggling, typically, but compared to modern development practices, I consider it to be a struggle. The main struggle is the feedback loop. How easy and how long does it take for them to get feedback on the code that they are writing? So I don't even want you to think about modern DevOps practices of automated tests that are run automatically when you do merges and commits to your GitHub repos. I'm talking about just, when you're developing locally, you want to be able to press a button, F5 if you're like in Visual Studio Code. You want to press F5, run it, see it run, see what's happening, maybe step through if you can. Now, there are debugging tools on the mainframe that I've seen where you can go step by step, line by line. But again, it's just not a an ecosystem or a platform that makes it easy to evaluate the code that you're writing and get those fast feedback loops. I may have just insulted some people right there. I may have just upset some people right there. But that's the bottom line, that developing on a mainframe in COBOL is not a good developer experience. And there are very few, if any, tools that, and especially tools, they're open source is just about non-existent on a mainframe. So any tools that do exist are very, very expensive. So I wanted to make a better life for COBOL developers and mainframe developers. And also as a personal challenge, is this something that I could do? So I started to develop this COBOL to Python converter. Take COBOL statements, convert them into Python syntax, and have it run as if it were running on a mainframe. The logic branching, the conditioning, the conditionals, the assignments of variables, whatever it would do it the same as if it were on a mainframe. My hypothesis for this is simple: the faster we get feedback, the faster we can make updates to our code to make it better and solve the problems that need to be solved and provide the value that we want to provide. The other thing that I've seen, which is a quality of life situation for COBOL developers, is the way the code is structured. It's not good. There's just no other way to say it. It's not good. The cognitive load that is placed upon the COBOL developer is immense. COBOL is supposed to be, or was intended to be, when it was written back in the 50s and maintained for 50 or 60 years now, it was intended to be more of a natural language processing. The problem with that is, and I know we got ChatGPT and all of those things. This is not that. The problem with natural language processing is, especially the English language, is not great. Words mean different things. Two words sound exactly the same, but they're spelled differently. Words have different contexts depending on the way that they're used in a sentence. And generally, it's about the way human beings make connections in their own brain to get from point A to point B. And since everyone is unique and we have our own experiences, we have our own memories, we have our own knowledge, the way that we arrive at the same place, two people arrive at the same place, is different because the connections within our brains and the memories and all of those things are different. So even though the outcome, two people may get to the same conclusion or the same answer, they got there in different ways. So trying to make a more unstructured programming language really makes it that much more difficult when you get to the compilation step. So this is why opinionated languages exist, such as the C-based languages, or Python, or any of these other languages that have a more strict syntax structure. Why? Because it's easier to parse when it comes to compilation time. So, taking all that into account, this is a pretty daunting task, and ultimately, will it be successful? I hope so, because I really do want to improve the quality of life of a COBOL developer. Okay, so let's start with just looking at code. We can read the README that I put up on the GitHub repo all day long. That's not what this is about. This is about showing working code. So we'll go ahead and clone the repo. And we can see what we have in here. Basically, on the root of the project, we have a lot of scripts. So I have bash scripts for Linux and Mac. I have batch scripts for Windows. And this is the main way that you can interact. If you're not using an IDE, you can interact with the functionality of the mainframe emulator. Let's go ahead and open Visual Studio Code. And get a little bit deeper into the directory structure. The converted directory is going to be where the final COBOL to Python converted file will reside. We'll skip these for now. Copybooks, we're going to get into those, what those are, in a later video, if you're not familiar with COBOL programming. Data is, for some of these examples, I read in files, so I just created a directory structure, data input files, and then whatever files I wanted to put in there. Dependencies has some helper programs, helper Python programs to emulate the functionality, the execution of the code as if it were on a mainframe. The main dependency that you want to think about is the COBOL variable file. So this has a lot of helper functions and classes within it to, accomplish the tasks, accomplish the code execution that we want to convert from COBOL into Python. So this is going to get copied to the converted directory whenever you do a conversion from COBOL to Python. These other programs, they are COBOL programs. I'm not going to go into them right now, but they're little helper programs. Like this one actually is a standard program on a mainframe. When you have a catastrophic failure, you can call this from your COBOL program through its error handling, quote unquote, functionality, and it will basically just kill the program right then and there with an error message. So since CEE3AB2 exists on the ZOS operating system, and it's available to call from a COBOL program, I went ahead and emulated its functionality here. And this is, even though I wrote it in COBOL, it was more testing of the emulator that I'm working on. It will convert to Python. A random string generator, because there is no random string generator native to COBOL. And so I wrote one. But let's begin at the beginning, which is always our hello world. This is the most simple program you can write in COBOL, I think. It's print, print to the screen, hello world, stop execution. And we're done. In order to use our emulator, we're going to look in the source directory. Cobra main is the main COBOL to Python converter. How did I come up with the name Cobra? I hope it's pretty evident. Python COBOL, snake. What's a snake that starts with COB? Cobra. So there you go. Everything has a snake metaphor going forward. By specifying the COBOL program we want to convert, the Cobra main will then call some of these other modules, and it will parse the instructions in the COBOL program, convert them to Python. Let's go ahead and do that now. Now, since I just cloned the repo, we're going to have to go ahead and give executable privileges to our bash scripts. And I'll do this one, strike. So, to use the COBOL converter, COBOL to Python converter, you just execute the Cobra sh, specifying the program you want to run. So it's examples, and then if we look up here, it's hellowo1 underscore basic.cbl. Where do we want the converted file to reside? In the converted folder. Run that. It says it was complete, and you can see here we have our Hello World 1 Python file. The name of the Python file is going to be the same as whatever is specified in the program ID of the COBOL source file. Every COBOL program needs what's called a program ID. This is the ultimate name of the executable that is created after compilation. So I'm emulating that behavior the same way. The first thing is I create a class with the name of the program ID. So hello, in this case, Hello World 01 class, or Hello W01 class. I'm going to get into some of this stuff in later videos, but the basic idea is we're initializing our class. Then our class has a main function. And we can ignore these lines for right now. I'll get into those into later videos, but we can see here are our equivalent lines. Display hello world, and then stop run is the return statement here. I also create this Python trick so that if this is the main file that's running, we're going to create an instance of the class, and we're going to call the main. So, using our snake metaphor, when we want to execute a program, we're going to strike, and then we're going to just specify without the folder, because we know we're going to look in the converted folder. By default, the converted binary or executable name without the py extension, that'll be added automatically in the bash script, and we can see hello world has been printed out. So there you go. That's the most basic, simple thing. Great. Not really useful for people that want to use this in their day-to-day, but it is a starting point, so we iterate. So we'll go to the second example program, which now has variables in it. So as you can see, we declare a variable here. We call it hello world. We give it a data type, which is the picture clause. X means alphanumeric, so it can be any character whatsoever, within the 0 to 255 range. and then for a length. Every COBOL variable has a fixed length, and every COBOL variable is global to the COBOL program where it was declared. There is no scoping or encapsulation within COBOL. There are no functions with their own scope within COBOL, within a COBOL program. The COBOL program is the scope, and two COBOL programs can talk to each other. We're going to get into that in a later video. But basically, the memory needed for a COBOL program is determined at compilation time, so that at executable time, at execution time, that much memory is sliced off for the COBOL program. And in the mainframe world, I did research on this, it is a continuous slice of memory with no breaks. So wherever it starts, we'll call that position well, in COBOL, it's position 1 because it's 1-based, not 0-based. But the first position of position 0, and it goes all the way, taking up as much memory as it needs without break. One variable right after the other, stacked up in that memory. Anyway, let's go ahead and convert this so that we can see it execute. Examples, hello world 2, and we'll put that in converted, and that's complete. So you can see here we have, our executable name of hello world 02 or hello W02. So let's go ahead and run that. And we can see we had the expected value of hello world, reading the value of the variable. Here, it came out hello world. So that's good news. Now let's get a little more complicated with our variables. So as you can see in this program, we have defined the hello world variable, but instead of giving it its own picture clause with a data type and length, we have sub-variables underneath of it. And not only that, we have several sub-variables and sub-levels. So hello world is made up of the hello string, that is a length of 5, I'll get into this, the hello space, which is a length of 1, and the world string, which is then a length of 5. The hello string and the world string are then further subdivided into the first 3 characters and the last 2 characters, and then the first 2 characters and the last 3 characters. So, as I was saying, the variables are stored in memory in a continuous line, and then you can reference the position and the length of that memory that's set aside. So hello world itself is in position 0 for a length of 11, because all of its sub-variables, whatever level they're on, children, grandchildren, great-grandchildren, however you want to look at it, added up, they equal 11. So I can reference hello world, but when I do, I'm referencing those 11 bytes every single time. If I'm adding, or if I'm assigning a value, it assigns all 11 bytes. If I am reading the value, it reads all 11 bytes. I can also reference hello string. That starts in position 0. But its length, its total length is a 5, because the sub-variables equal 5. So when I reference hello string by itself, I'm only referencing those 5 bytes starting at position 0. So if we were to change this, I could say display hello string and save this, convert it, execute it. Oh, that was 2. My apologies. We are on 3. All right, so we will execute hello world 3. So you can see, not only did we reference hello world, which was all 11 bytes, and up here we assigned hello world all 11 bytes. Then we read all 11 bytes. Then on this line, we read just the first 5 bytes of hello. So just out of curiosity, let's see what happens when we move hello. Actually, we'll move something else in there, ASDF. Oops, you didn't see that. We'll move these first 5 bytes into hello world. Save it. Convert it. Run it. Even though I only moved 5 bytes in, I moved it into hello world, which is 11 bytes. That means I intentionally wanted to reference all 11 bytes. So therefore, the last 6 bytes are spaces, because they were not specified here. That's the way COBOL works. If I only wanted the first 5 bytes, then I should have just referenced hello string. So if I change this back to hello world, and then I wanted to just change the first 5 bytes, then I would move ASDFE to hello string, save it, run, convert it, run it, and you can see it was first hello world, and then I changed it to hello, or to ASDFE. But just to show you what would happen, let me change this to hello world again. Convert it, run it, and you can see with a second move, I changed the first 5 bytes while leaving the other 6 bytes alone. So this is the hierarchical nature of the COBOL variable memory system. This added a level of complexity, I'm not going to lie, because when I reference this, I have to know how big is it. It's 5. So you basically have to find all of the children of a given variable. If it doesn't have an explicit assignment of data type and length, then you have to look at the children and say, okay, this is actually, however big, the sum of all my children. So these here are not explicitly defined because they are the sum of all the children. And you can have children of children and grandchildren and great-grandchildren and all the different children. You got to go all the way down so that you can always come back up to whatever the parent, the ultimate parent is. Okay, that's enough for now. Video 1 is complete. Thanks for watching. Stay tuned for more videos as I go through COBOL and the challenges I had converting it to Python. Until next time.